Hello. I'm going to be going over SCR 46 Project 1 on the simulator. I'm going to start it right away because this baseline measurement stuff kind of takes a while on the hardware. And then I will give a brief overview while that's going. So our banner prints out, and right now it's calculating basically how many increments before delay is done, and then it's doing the same for with the LED update function for 10 seconds. So yeah, in the main file we have the main entry point to the program where we initialize everything, including the UART init, LED init, RTC, so everything gets initialized up there, and then we do that baseline performance in this section, and then we enter the infinite loop, basically the continuous loop, where we update the LED finite state machine, and we continuously print out the RTC date. For timer 1, this class, in quotation marks, basically sets up the hardware for the 16-bit timer 1 on the Atmega 328P. So all of the registers need to get set appropriately for init. So we set it for a 1-second tick compare, set the CTC mode, and then we set the clock divisor, and we enable interrupts on output compare A. The timer 1 gets the count of the current count value of the timer, which is incremented by the interrupt, which I'll go over later. Timer clear basically sets that count back to 0. And then this is the interrupt handler, so every time the interrupt is flagged, increments up the count. Then we have LED. I'll check on this. Okay, it's still going for that baseline stuff. For LED, we just have a couple functions here where we set blink, and you can see that the light has just gone off, meaning it's doing the LED update portion of the profiling. So getting close to the end there. So set blink, it basically sets the blink message as a array of characters or char values that's passed in. And then it also sets that blink position to 0, and it defaults to phase 1 for the finite state machine. And then we set the delay to 0 for that 0 instance in the delay class, which we will see next. I'm going to move this over. And then you also want to make sure the LED is off. This is a set delay and LED method, basically for easy controlling of the delay and LED on off. It breaks out from the finite state machine. So instead of writing all that code in here, once we enter phase 1 of LED for the finite state machine, we run into that method where it sets the appropriate delays and LED on or off. Makes it a little cleaner and easier, I think. So this is the finite state machine. So you see, we want to make sure the delay is done before going back and changing or updating it. So we want to make sure the blink message is not 0, basically a null pointer, and we want to make sure the delay is done. And then we can break into this. So depending on what state the machine's in, we can do the functionality for phase 1, and then, or else we can do the functionality for phase 2. So depending what phase you're in, you will do these different functions. In delay C, we have our init, which is similar to timer 1 init, except this is the 8-bit timer. It's a little easier to set up, so you set that up for a compare for 1 millisecond tick, and then you're going to set CTC mode again for this timer as well, and then we want to enable interrupts again, and then we're going to set initialized to 1 so the delay is initialized. Okay, so I'll go over this in 1 minute here. Basically, you can see this is the baseline without the LED, and this is the baseline with the LED update. Okay, so yeah, so we initialize timer, delay get, again, you're going to get the count for the specific instance that's passed in, and delay set is you're going to set the limit for whatever delay instance you've passed in, so the time limit in the delay instance, and then you're going to set the count to 0, so you're basically starting up that delay. Delay is done just sees if the delay is finished and returns 1 if so. And again, we have another interrupt handler where we increment each instance of delay up as long as it's below the limit. So again, yeah, this is the baseline without, so that's how many increments count had gone through for the delay to be up. Our C1 in this particular, C1 in this particular case. So if delay is not done, it's going to increment it. So that's how many times that has incremented. And then this would be that C2 for that LED, including that LED update. And then, yeah, so we print that out. And then you can see we are printing out the RTC date, and our LED is being updated. Awesome. Thank you.